Alright, hey, gonna do these last two problems for you, so hopefully by tomorrow you'll be ready to go. Let's just hop right to it. Again, maybe most importantly here, show your work and show your work neatly. For part A, we're gonna find the derivative, so to find g prime, we're gonna take the limit as h approaches 0 of, it's gonna be 8 over x plus h plus 3. And then we're going to subtract from that regular old g of x, which is 8 over x plus 3. And we're going to divide that all by h. Okay, so now this is still the limit as h goes to 0. But we're going to swap a few things around. First thing I'm going to do is go ahead and just multiply by the reciprocal of h instead. So we get a 1 over h. Then we need a common denominator. We know that common denominator is going to be an x plus 3 times an x plus h plus 3. And we know that in the numerator, this guy's getting multiplied by x plus 3 over x plus 3. So upstairs, we'll just see this 8 distribute into that. So we'll get 8x plus 24. Then here, we're multiplying by x plus h plus 3. Over x plus h plus 3. And so we'll see a negative 8 distribute into that. So we'll get a minus 8x minus 8h and a minus 24. And if you do all that, that's a 24, by the way, looking like a 29, it's 24. Then we see a bunch of stuff cancel now. We've got the plus 8x and a minus 8x, those cancel. Then you've got a plus 24 and a minus 24, those cancel. So that's going to bring us down to the limit as h approaches 0 of just the negative 8h over x plus 3 and x plus h plus 3. Now we're multiplying by 1 over h, but this 8h, right, this is really two factors. It's a negative 8 and it's an h. And so I can go ahead and cross-reduce this h with that h. And now that that h is gone, we can find our limit by directly substituting in the 0. So that's a 0 going right here. So this x plus 0 plus 3 just becomes an x plus 3. And we see that our limit is going to be a negative 8 over an x plus 3 times a second x plus 3, so that'll just be x plus 3 squared. And that's going to be our derivative function. This is g prime. So that's it. Now we're trying to find the equation of the tangent line when x is negative 1. So we know we got to do two things. We know that in part B, we're just trying to find the coordinates. So for that, we're going to plug into the original function g of x, which was 8 over x plus 3. And we're trying to find g of negative 1. So that's 8 over negative 1 plus 3, which is 8 over 2, which is 4. So the coordinates of our point of intersection are negative 1, positive 4. Again, make sure you give that as an ordered pair. Now in part C, we're trying to find the slope of the tangent line. So for that, we're going to plug into our derivative function g prime, same one we found in part A. So that's negative 8 over x plus 3 squared. And again, we want the slope at the same x value at negative 1. So we're going to get negative 8 over negative 1 plus 3 squared. That's going to be negative 8 over 2 squared, which is 4. So that's giving us a slope of negative 2. And so now finally in part D, to actually find our equation, we'll use our point slope form. The y minus y1 equals m times x minus x1, which means it's y minus our y value, which is 4. It equals our slope, which is negative 2, times x minus our x coordinate, which is negative 1. And now we're just cleaning this up. This will be a y minus 4. If I distribute a negative 2 in, I'll get negative 2x. Now negative negative was a plus, then you hit it with a minus, it goes back to minus 2. Then you add 4, and we get our final answer of y equals negative 2x. We're adding 4, so we'll end up with plus 2. And that equation there should be the equation of our tangent line. And that's it for a rational. Any other rational should work pretty similarly to that. Let's do the radical one now, and then we'll be all done. So looking at this, we've got j of x. And we're going to run through all the same steps. In part A, we'll find an algebraic rule for our derivative. Part B, we'll find our point of tangency. In part C, we'll actually use the derivative we found in part A to find the slope of the tangent line. And then we'll write the equation of the tangent line. So let's do it. In part A, again, we're going to use our limit definition, which says that j prime of x is going to be the limit as h goes to infinity of j of x plus h minus j of x all over h. That's just our formula. Make sure you have that memorized though, because I'm not going to give it to you. So this is going to be the limit as h goes to 0 of the square root of 2 times the quantity x plus h minus 1, then minus j of x itself, which is root 2x minus 1, and then this whole thing is all over h. And we know that to clean up a radical expression like this, we'd want to multiply by the conjugate. So that's going to be a root 2x plus h minus 1 plus root 2x minus 1. And we're multiplying by that in the numerator, but also in the denominator. All right, so now when we multiply this out, it's still going to be the limit as h goes to 0. And then upstairs, when we do the first times the first, it'll be this radical times itself, so the radicals will cancel. So you'll just get that radicand. We'll get a 2x plus h minus 1. Then when you go to do your outers and your inners, we know that those will cancel out, so I'm more concerned with just doing the last times the last, which again is another radical times itself, so you'll just get what was underneath. You get the 2x minus 1. I would put that in parentheses if I were you, because we know that we're going to subtract that whole thing, so that negative is going to want to distribute in onto that. Then downstairs, we've got this factor of h, and then we've got the whole conjugate too, which is going to be the square root of 2x plus h minus 1 plus 2x minus 1, or root 2x minus 1. Okay, so this looks bad, but it's not bad really, because we know we can clean this up. Specifically in our numerator, once we start distributing, we'll see stuff cancel out in big chunks. So the limit as h goes to 0. In the numerator, we distribute this 2 to get a 2x plus 2h. And then still just a minus 1. Then distributing this negative gives us a minus 2x and a plus 1. Downstairs again, we've just got h. I don't know, I kind of want to distribute this 2, but I'm not gonna. It'll be 2x plus h minus 1. That's a big old root. Then we're adding to that a 2x minus 1. That's a big old root. So there's everything. I know it's a lot, but now we get to clean it up, because 2x cancels with negative 2x. Oh, I screwed something up. Same mistake I made in the first video. So when I distributed that, it was a 2x and a 2h, and I guess I just wrote 2x, 2x. But that's an h. So that's not going to cancel, which is fine. We don't want it to cancel anyway. but we do want this minus 1 to cancel with this plus 1, leaving me with just an h in the numerator. And again, we know now that that 2h is the only thing left, we can cancel that h with this h. Now all we've got in the numerator is a 2. So we are now going to keep on cleaning. We've got 2 over, and I am going to go ahead and substitute in 0 now. When I substitute that in, that means that in the denominator, this is just an x plus 0, so that's just x. So this is just a 2x minus 1, which is the exact same thing we had over here, a 2x minus 1. Which means I can combine those two radicals in the denominator. I get 2 over 2 root 2x minus 1. But these 2's can cancel. That coefficient, or that numerator, cancels with that coefficient. We get a final answer that says that j prime of x is 1 over 2x minus 1, root 2x minus 1. But there's our derivative function. So now we can go back and do everything else. So that's all part A. Let's get down to part B. In part B, we're just looking for the coordinates of the point of intersection. So take your original function j of x, which looks like it's root 2x minus 1. And we are trying to get the tangent line at 5, apparently. So let's find j of 5. And that's going to be 2 times 5 minus 1, which of course is 9, and root 9 is 3. So that means our point of tangency is the ordered pair 5, 3. Okay, so in part C, we know we're going to look for our slope of our tangent line. So for that, we grab j prime, our derivative function, which is 1 over root 2x minus 1. And we're still plugging in 5, so j prime of 5 will be 1 over, and it's the same root 9 from before. It's going to be 3 again, so that can be our derivative. This is our slope, this is our m, so we'll take that. And then finally, to find the equation of the tangent line, we'll plug into our point slope form, which is y minus y1. And x minus x1. So our y coordinate was 3. Our slope is a third. And our x coordinate is 5. So just clean this up and we're good to go. This will stay y minus 3 for the moment. We'll distribute a third. We get 1/3 x minus 5/3. Now we're going to add 3, so we get y equals 1/3 x minus 5/3 plus 3. Now this 3 is over 1, and to get a common denominator, we want thirds, so we'll multiply by 3 over 3. And we see that what we've really got is a y that equals 1/3 x minus 5/3, but plus 9/3, which gives us a final answer of y equals 1/3 x plus 4/3. And so there's your final answer for the equation of the tangent line, which almost fit. It fits fine. All right, but that's the final answer. So there you go. Sorry I had to split this over 2 videos, but by now you should be feeling pretty good about polynomials, even including polynomials that had cubics in them. Hopefully you feel fine about how to expand a big old cubic. You should be good with rationals. We did that today, just now. And you should be good with radicals. We just did one of those too. So following that all the way down, there's everything. This is just about all I intend to put on the quiz. On the quiz, maybe I'll pull back some gems from the delta math. Maybe I'll give you a graph, and maybe I'll still expect that you can eyeball some derivatives. Maybe I could ask you, I don't know, where does the derivative equal 0? I assume you can picture that there's a horizontal tangent line there, and a horizontal tangent line there, and a horizontal tangent line there. So where does the derivative equal 0? And then maybe all these things are numbered, but there would be one at -2, there's one at +3, and there's another one at 7 or something. Maybe I would ask you just, eyeballing the derivative here. That derivative is negative, right? Negative and maybe about 1. And over here I could say, what about the derivative here? And you'd say, well, it's positive and it's a heck of a lot greater than 1. But I'll probably ask you something having to do with just eyeballing these tangent lines and ballparking the approximate value of their slopes. So maybe just be ready for that. Remember that a 0 slope is horizontal, a negative slope is decreasing, like this orange one, and a positive slope is increasing, like this blue one. I won't ask you to go much deeper than that. But again, the big thing on the quiz for sure is problems exactly like this, where I'm asking you to use the limit definition to get to the derivative equation. Then I want the coordinates of the point of tangency. Then I want the slope, and then I want the final equation. So hopefully you feel good about that. And we'll find out tomorrow. See you later.